In this video, I'm going to solve or find solutions for the polynomial cubic shown there, and I'm also going to find solutions instead of for f of x equals 0 for f of x minus 2 equals 0. I assume in this video that you understand synthetic division. Remember, the reason for this channel is to help you pass your math class so you can achieve your goals and get a better life. Finding the solutions to polynomial equations coming right up. In order to solve this problem, we're going to have to use the rational zeros theorem. So if we have a polynomial, as shown there, f of x equals a sub n, x to the power n, etc., and we know all of the coefficients, all the a sub n's are integers, then if we find a zero, and we call that zero p divided by q of the function, p is a factor of a sub 0 and q is a factor of a sub n. The first thing we want to notice about our polynomial is that it has degree 3. The highest exponent is 3 on the leading term there. So that means it has at most 3 zeros. We don't know that they're all real though. Some of them may not be. So what we want to do is graph this to get a sense of what the zeros might be. Well, before we do our graph, let's look at all the possibilities that we might have for possible factors. So a sub n in this particular polynomial is 3, and we know a sub 0 is 5. So this is going to correspond to p, this will correspond to q. So the possible factors of 5 are plus or minus 1 and plus or minus 5. And for the denominator, the possible factors are plus or minus 1 and plus or minus 3. So the possible factors for this polynomial are, well, we'll do them one at a time. Plus or minus 1 divided by plus or minus 1, so that's plus or minus 1. Plus or minus 1 divided by plus or minus 3, so that's plus or minus 1/3. Plus or minus 5. And then plus or minus 5/3. That's a lot of different possible factors. Remember, factors have the form x minus c. That's a factor. So I want to narrow this down, and I've already input the function into y1 of my calculator. So put the function into y1 of your calculator. Let's look at the standard screen. Let's look at Zoom 6 and see if that helps us narrow down the choices that we might have. And when I look at that, when I look at the graph, it seems to me from the calculator graph, it looks like x is minus 1 is probably a factor, and x equals positive 5 is probably a factor, and there's some kind of fraction that I can see there. And so I'm going to use synthetic division to test. So we're going to test x equals minus 1 first. And remember, with synthetic division, you bring down the first coefficient. These are the coefficients of the polynomial, and negative 1 times negative 3 is negative 3. Let's add those up. So I get negative 16. Negative 1 multiplied by negative 16 is positive 16. So that's going to give me negative 11 plus 16. That's a positive 5. 5 times negative 1 is negative 5. These add up to be 0. And of course, this is my remainder. And that shows me that x equals minus 1 is a factor. And in fact, I can write the whole polynomial as f of x equals x plus 1, and then what's left? So I have 3x squared using my synthetic division minus 16x plus 5. I can either factor that or I could use the quadratic equation. but I can see how to factor that. So to save time, I'll just tell you the factorization. But if you get stuck, once you know the quadratic formula, you can always use it. So this becomes 3x minus 1, and then this multiplies x minus 5. Hey, and that was the other factor that I thought. So x minus 1 and x equals 5 is a factor. So in order to find the zeros, that's my next step. And to find the zeros, of course, what I have to do is I have to solve f of x equals 0. Well, that's pretty straightforward now that I've got all of these factored. Now it's very, very straightforward to find the zeros. F of x equals 0, well, that means that x plus 1 all multiplied by 3x minus 1 all multiplied by x minus 5 equals 0. So it must be that either x plus 1 equals 0 or 3x minus 1 equals 0 or x minus 5 equals 0, and of course I get x is -1, which I already knew from the synthetic division. X is 1/3 or x equals 5, and they're the 3 zeros for f of x. We found the factorization for our function, and next we want to find this function f of x minus 2. And we're going to use the factorization. We're going to be really clever here. Everywhere we see x in the factorization, instead of x, we're going to put in x minus 2. So x minus 2 plus 1, that's equivalent to x plus 1. And then we have 3x minus 2 minus 1, and that's equivalent to 3x minus 1. Except, we're feeding in x minus 2, and this time we have x minus 2 minus 5 in the very last factor. So let's just simplify that. So we have x minus 2 plus 1, that's just going to be x minus 1. And here we have 3x minus 6 minus 1. And here we have x minus 2 minus 5, so x minus 7. I think I can simplify the middle one more time. So I'm going to end up with x minus 1, 3x minus 7, and x minus 7. So I've just found that f, when I feed in x minus 2 instead of x, is this factorization. So now it's going to be quite easy to solve for when f of x minus 2 equals 0, then I know that that's the same as x minus 1 multiplied by 3x minus 7 multiplied by x minus 7 equals 0. And of course, that's true when x equals 1, x equals 7/3, or x equals 7. I would like to invite you to like this video and subscribe to this channel. Thanks very much for listening.